Hi and welcome. This time around we have to make another welding fixture for this very unusual part. And as you can see, it's a very complicated part. And what makes this even more difficult is we need to orient this pin that's pressed in here dead vertical in the fixture because it's going to be welded around this. So on top of that, this fixture is for a rotary welding setup, and so this piece is going to have to sit inside here oriented perfectly, which I think I'm going to use this as my reference to get this rotated properly. But this depth needs to be right on because this needs to be at the center of rotation so that the laser, as a table rotates and goes around, will stay within a few thousandths of this line, which is the edge of the pin. So this is going to be a very challenging project because, among other things, I have to hold a round piece in order to bore a hole in the end. It's definitely going to be a serious challenge. So I have a feeling it's going to take multiple attempts, but we're going to try and get it right the first time if we can. The customer originally just 3D printed something that worked right off the bat, but additive manufacturing is a huge plus. Like, for example, how would you do a semicircular hole and have a pin or a slot sticking up in that semicircular hole when that diameter has to be very accurate? Normally, for, if you're not doing CNC machining, I would have to bore out the whole hole and then insert something like a pin, which is what I'm going to do, or a piece of key stock if you want square. Very, very challenging to do with manual machining. CNC, again, probably could pull this off pretty easily. This is a very complicated part with multiple diameters. Here's one, here's another one, here's another one, yet another one still. And we need to register off the back of this guy very accurately. One quick afterthought, getting this hole bored exactly right so that this part slides back and that's dead on center. Another thing I could do is just bore it a little bit deeper and then use a set screw with like a brass bushing or a plastic bushing so that this pushes up against it to set the depth. That way they can adjust it right on the money. That's another possibility. I'm going to try and get the depth right the first time, but I have a feeling getting within a few thousandths is going to be pretty challenging, especially getting a flat bottom on this guy. First step, we're just going to dimension some stock. Next up, we got to take this down to size, do 100 thousandths pass, and I'll measure. And we are on dimension 1.750. I've got to be pretty accurate about this, which is why I started with larger diameter material, because the depth going this way needs to be precise. So if I don't know the width exactly, that's going to be a problem. Well, and on top of that, if I just needed a certain depth, it wouldn't matter what this actual diameter is. I could just bore the depth and be done with it, right? However, I need to make sure that the depth is right with the point I need to be centered. That pin that's pressed in needs to be dead center on this, which means I need to know this position right here with really reasonable accuracy. So. All right, so there's our part. Moving on to the mill. All right, so we got the part loaded in the vise. Eventually I'm going to flatten off the top so I've got this overlapping so I can measure the amount of material I take off. However, I could start by taking that material off and try and get it right on the money. And then my measurements, I'd have to change the way my measurements dated are currently this top surface. That's not a particularly accurate way to do it. Plus I'd have to bore the hole through material that doesn't need to be there still. So maybe I'll start by machining the flat in this guy, and then I can adjust my depths accordingly. Next up, we're going to mill the flat, which will create my reference side, and I need this thickness to be very close. So I set my zero very carefully, knowing that in this inexpensive Chinese insert holder and inexpensive Chinese carbide inserts, that they're not all going to project down the same. And sure enough, as I walk this in, a few tenths at a time, as I rotated this, one of the inserts came in contact before all of the others. and that is my low point. Fortunately, I can just measure this, so I'm going to get the depth pretty close, and I'm going to measure it, and then I'm going to come back and remove the final bits after I have my reference measurement. .5942. I call that good. A couple tenths. Next up, I'm going to use a center cutting end mill, and we're going to go to drill the center part of the hole out. We're going to use end mills to remove the vast majority of material. You know, a boring bar in a boring head needs a hole to start with, so we're going to remove as much material as we can first. So we're going to try and get our depth right here. Total depth we are looking for is going to be 1.073 from the flat. I had referenced everything off the round part. 1.073 off flat, so we're going to go to 1.050. So now if I did this right, that's actually 1.060, so I went a little farther than I intended to. But now I can get a depth mic in there and see what it actually is. I'm kind of curious. I still have 20 thousandths roughly left over, so it should be good. So that worked out being pretty accurate. We were 1.058 instead of 1.060. So not bad at all. Now I've got a 1-inch end mill with a 3/4 inch shank. It's in a Welding holder, has a Welding flat. So we're just gonna work our way down to about 1.060 again. I want to slow this down. This is a 1-inch end mill, so let's see if this is slow enough. Okay, 1.051. I've changed my mind, decided to punch a 1/2 inch hole all the way through this. All right, so right now the hole is 1.047, and we need to go to 1.196. So let's see if we can do another 30 thousandths. And I'm going to try and do 33, 10, 20, 30. Three. Couldn't quite figure it out. Something was causing vibration in this. A lot of times you got to be careful about setting the angle of approach for your cutter when you're using a carbide insert one like this. You got to make sure it's turned back enough that you've got relief behind the cutter or it rubs. But I was getting chatter the whole time. Totally screwed the part. Now I got to start all over again. Love it. All right, so we're on our second one here, and I've got the tri-mic in here. We're at 1.081. So now I need to dial in 8 thousandths, maybe 9 thousandths of total diameter. So what I'm going to do, rather than trust the little marks on this dial here, is I'm going to put an indicator on the other side of the boring head and use that to do the adjustment so I can get accurate results. All right, so I got a dial indicator on the boring head here, and I got it set for 0. It's hard for you to see that. If you're right above it, it is 0. Parallax makes it look like it's off. So I'm going to loosen the locking nut and adjust this guy. And I got to remember this is radial units. So when I go up 1,000th, that's actually going to take 2 thousandths off. I cannot forget that or I will get hosed. Last pass. Should be right on final dimension. Now for the test fit. Now I noticed this pin they've got in here that's pressed in. You can see inside there. That's actually sitting proud. Now I am going to machine off the whole top of this. I just wanted it to be there because I don't want it to be an interrupted cut, because then I might get the cutter to deflect a little. So it's hitting that pin that's a little proud. So I don't want to make this any bigger because the spec has this dimension, this size, and then up to 5,000 smaller. So we're just going to try and go with this. Next I need to bore down 0.325 inches for this little 7,000th larger diameter section. And we're going to do that next. There we go. I went 350 to give me a little bit of extra. Now this little bit here that's proud probably will clear that section. Yep, and it's just going to catch down below. All right, well, I think we're on the right path. All right, so now, before I pop this guy out of here, I need to drill and tap for the pin. So you'll notice that, let's see what you can see here. So you'll notice that where the pin is pressed in, which is where they need to laser weld around, directly opposite that is this guy here. And so I need to drill and ream a hole for a pin that is going to line up directly with this guy, and let me set this guy in there so it clocks correctly. Then what I'm going to do is I'm going to remove most of the top of this. Again, I did a full circle and I cut it completely because I didn't want to risk an incomplete, an interrupted cut, deflecting the cutter. Every time it leaves, it springs out, and when it enters, it springs in. So rather than have a little bit oval, I opted for this, which will make a rounder hole. Unfortunately, this diameter can be 1.189 minus 5 plus 0, and this is minus 3. So the fact that it's still this tight, of course, where this pin is sticking proud, there's not going to be any material there, so that won't be a factor for the fixture. It's just with 5,000 slop, that's actually quite a bit of slop in a fixture, and I don't like it, but anyways, we're going to deal with it, I guess. So next up, we're going to drill and ream. Actually, drill and ream is not quite right. I still need to face the bottom of this because the depth is off by 1 or 2 thousandths, I think. So I need to use the boring head that allows it to, you hold the top and it opens up so I can face the inside of this, because that's about the only easy way to get in there. So I think we're going to need to do that. Now we're going to use the facing feature of this boring head. So what I did was I touched bottom with the boring bar and zeroed this out, locked off the quill, zeroed the Z-axis, and then lifted it off. And I'm going to move it into the part and then hold this and have it go out. Okay. To 1,000th, I guess. When it gets to the end and hits the outside, it'll just get tight and I'll let go because I'm only holding loosely. There we go. And I set my Z knot. And got to back this guy out of here. Back to the middle. All right, so let's see, how do we do this? I could bring the quill up because I do have it zeroed out. So we can do that. Ooh, something touched. But it did face off the bottom pretty nicely. All right, let me offset this so I can make a measurement. So we are looking for 1.073. Oh, this can happen, by the way, if you don't tighten that well. So I was going, geez, I'm way off, which makes me wonder if I've just gotten hosed and everything else. Let's see. That's 73 on the money. Holy cow. Okay. That's right on the money. Okay, I think we nailed it. Wow, I didn't think I'd get the first shot. 73, 1.073. If this loosens up, that's how you replace the needles in this guy. And so if it's loose, then the needle can come back up. I know you can barely see this, but this hole is going to be really close to the edge here, which is exactly what that part is. And it should just line up. Ream it. The reamer only needs to remove about 4 thousandths of material. I found out recently, at least it makes sense, an explanation of why reamers are so long, because they want a little bit of flexibility in the tip so that it can follow the hole properly. I don't know how true that is, let me know. I guess we're going to part this guy off. We're going to have to be gentle because it's very interrupted. All right, let's see what we've got. Threw up a nice burr, that's for sure. So the question is, do I want it on center? I decided to start up here first. So this part goes up. That's a really good fit. The burr there is kind of making it tight. Let's throw a chamfer on the outside. There we go. That was good. Just need to do some hand sanding here, deburr this edge, and I think we're good to go after we get the pin. There you go. So the pin gets pushed in from the back. The length I ordered should be just right for the pin to stick out exactly enough to line up like so. Just like that. It's a nice snug fit. Hopefully it won't be too snug for him. These parts vary in size quite a bit. I went with the high end of the size, so it should be fine. I guess we'll find out. Last thing I had to do is take some Kratex and polish up the inside of this guy. Then I had to put the dowel pin in, which I got to a point. I basically put that in chucked it up in my drill motor, went over to the grinder and ground it. Not the surface grinder, but the bench grinder. So that alignment pin lines up here, and the bevel helps guide the part in. So all you have to do is close, push it in, and we are good to go. this part done.